Hello everyone. Welcome back to a series of live discussions. Let us welcome Mr. Ashwini Kumar Sinha and Mr. Suresh Trivedi ji for today's live session. The topic of today's live session is solid state relay versus electromechanical relays. What is the main purpose of relay in the applications, like for example, frequent switching or heavy duty operations, etc.?
Okay, so relay is generally used for the switching. It's either the high voltage, low voltage, and it either be needed for the frequent switching or non-frequent switching. So basically, the main function of the relay is that it lets you to control the any switch, any other switch that is totally isolated from one circuit to the another circuit, and that can be switched using the signal. So suppose that I have a IoT hub or IoT controller. Then you might have seen those IoT controller that using which you can control the home lights or TV fans, AC, cooler, fridge using the voice that we have seen in the market. What do they have? They have the same thing. Either they have the relay, or they have the solid state relay or the electromechanical relay. So overall, they have the relay on them. So what it do? It have the DC circuits in it that do the processing and all other things, and then use the relay to switch that other circuit, that is your fan or AC or whatever. So both circuit are totally isolated. The circuit that is AC circuit, my fan, my AC, my room, that other side circuit is AC circuit is totally isolated from my DC circuit. So using my DC circuit, I am giving the voice command or doing the processing and giving the signal to the relay to turn on the AC circuit. So both of the circuit are totally isolated, but they are electromagnetically connected with each other using the relay. So so you, so we use the relay to control the different appliances from the some kind of signal. It's either be some DC signal or some kind of other signal, PWM signal. So it's depend on us what kind of signal. Relay is generally used for the switching using some kind of signal, and we use those relay in controlling or turning on and off apply of various kind of appliances. It either be the DC current, or it either be the AC based current, or it either be the low load current, or it either be the high load current. So it's depend on that, but relay basic function is for switching using some kind of signal.
Okay, so as you told us that a relay is working like a switch. So, how it is different from a switch and why it is needed in a circuit? सुरेश सर
हेलो हेलो
yes sir अब
Yeah,
आपकी आवाज आ रही है
a relay is an electrically operated switch used in the circuit for the several important reasons, such as its isolation. It is the electrically isolation. Relay can provide electrical isolation between the control circuit and the load circuit, protecting the controlling device from the high voltage and the current. Second reason is the control of the high power. High power switching. Suppose there is a high 10 ampere load you want to operate, so the relay is important. You can control through the microcontroller or any other devices. Is control the heavy loads. So in the between you need a relay. So relays allow low power circuits to control high power circuits, enabling a small signal to switch on or off a much larger current. Third is that you can control from the remote area. So this enable the control of circuit from a distance, useful in applications where the controlling and controlled circuits are physically separated. Both are at the different places. And the third one is the automation and safety. The relays are used for the automation system for various control functions, and it is also used for the safety purpose. So It provides safety features like overload protection, preventing damage to the circuit. So we use the relay instead of the switches. Another is a multiple contact, because relay has a multiple contacts, pole and throw. So relay can have multiple contacts such as the single pole double throw through SPDT, double pole double throw means you can control two load simultaneously as a DP DT switches. Allowing them to control multiple circuits simultaneously means you are using a double pole double throw means you can control two loads at a time through a single control, right? So this is the another. Now the question arises, what is the difference from the switch and the relay? So first is the operational mechanism, electromechanical versus the manual. Relays are electromechanical device operated by the electrical system. The standard switches are manually operated. In this case, you can control through the microcontroller or any other devices. Another is the electrical signal. Relays are controlled by an electrical signals, while typical switches require manual or physical actuations. Another is application, high power application. Relays are suitable for controlling high power loads, and the circuits where switches are designed for the lower power circuits. So using this relay, you can control the high power, while manual switches are need for the low power applications. Another is the functionality. Relays can design to perform complex functions such as time, delays, latching, and sequencing, which are not possible with the simple switches. Third is the durability and reliability. Contact life. Relays are designed for the numerous cycle and can handle high current loads more reliability than the mechanical switches. Now you can see the few examples where the relays are normally used. First, as automotive, industrial automations, home appliances, right? These are the various applications and the most. So in brief, you may say that the relays are the essential in the circuit for controlling high power loads with low power signal, providing electrical isolation, enabling robot control, and allowing complex control schemes, distinguishing them from the simpler manual switches.
Okay. So, what are the voltage and current requirements of a relay?
Very good questions. So voltage and current requirement of the relay depends on the two main aspects. One is to control coil circuit and another is the load or contact circuits. Here, for example, coil and voltage requirements. The coil voltage, this is the voltage required to energize the relay coil. Common coil voltage includes 5 volt, 12 volt, 24 volts, 48 volts DC, 120 volt AC, and 240 volts AC. Uh, Specification of relay based on your requirement. If you have a circuit for the 5 volt, then you need the 5 volt. When you have a circuit for 12 volt, then you need to, basically, these are there. Similarly, the coil current is also important. Current required to energize the coil at the specified voltage, the typically a small current is required. For example, if relay for the 12 volt DC coil might have 30 milliampere to 100 milliampere current only. Suppose you are using a 12 volt DC relay, then its voltage is 12 volt and coil current should be up to 100 milliampere. Right? So another is contact voltage and current requirement. The contacts are the part of the relay that switch the loads. Contact voltage means the load which you want to through the loads in contacts. For example, this is the maximum voltage that the relay contact can switch. It can be AC or DC and often has different ratings. For example, if a relay might be the rating of 20 volt AC or 30 volt DC, depends on the load. And similarly, the contact current is also very important, and it is the passing through the contacts of the relay. That is the reason it is known as the load current. This is the maximum current that the relay contacts can handle when switching the load. Suppose you are controlling through a microcontroller, then the load which you want to energize or actuate, so that may be higher. For example, relay might be rated for 10 ampere at 24 at 230 volt AC, etc. So these are the few parameters. So in case, so our typical relay ratings are various. For example, small signal relay, 5 volt DC. Suppose you are having a 5 volt relay, then its a coil current is around 30 milliampere. Contact voltage means its contact, you can use the load for the 120 volt AC or to 24 DC, even up to 1 ampere. Another is power relay. Coil voltage is 12 volt DC. Then coil current is around 75 volt milliampere. Sorry. So power relay may, if you are using a 12 volt DC relay, the coil current is around 75 milliampere. The contact rating is around 250 volt AC or 30 volt DC, whatever you want, up to 10 ampere in case of the 12 volt DC power relays. And another is the industrial relay. It is very important relay, and it is normally it's the industrial coil relays having the coil voltage is around 24 volt DC and the coil currents are around 50 milliampere, while the contact voltage are 480. Even you can use the three phases in this case. And the maximum current, contact current of the industrial relays are around 30 amperes. So these are the few parameters. So for consideration during the selection of the relay ratings, first of all, you have to consider coil current tolerance, ensure the current control voltage is within the specified tolerance. Inrush current, some relays might have an inrush current higher than the steady state current when the coil is first energized. Contact rating is very important parameter. Ensure the contact voltage and the current rating meet or exceed the limit of the load to prevent the control or damage or failure. AC versus DC rating. DC contacts usually having different ratings for the AC as well as the DC due to the difference in the how they handle the arcing, means sparking, etc. So, in brief, you may say that when you are selecting a relay, ensure that the coil voltage and the current matches your control signal and that contact voltage and current rating are suitable for you. Always refer to the relays database when you are using the relay. That's all.
So, what are the environmental conditions like temperature, humidity, or vibration in which the relay will operate?
Yeah, so there are various category of relay that are available in the market. Few are for high temperature that can able to withstand those high temperature, and few are for low temperature as well. There are a special kind of relay, but generally the relay that we found in our consumer electronics devices or found in our general electronics, then they are actually work in between the range of -40 degree to +85 degrees centigrade. So generally the relay that we found in the market and that we usually do in use in our DIY projects and other projects are under this rate. And for the humidity thing, they can operate from the high percent to 99 95% in non-conditioning relative humidity. So non-conditioning relative humidity means that the water inside the environment should not be condensed out and forms a droplet on the relay that you might have seen in the you know on the water bottle. When you bring the water bottle from the fridge, then the water condense and the water droplets out there. So 95% non-conditioning environment it can be tested, because if there is a water condensation on the relay, and then it might be create the short circuit because of those water droplets between the two contacts of the relay. And third is the vibration consideration. So the relay electromechanical relay and other relay can withstand with high vibration like 10 to 55 hertz, and they can mostly be used in industrial and automotive as well. Relays are mostly be used in industrial and automotive as well. And some solid state relay can even withstand much more higher vibration, because the normal relay that electromechanical relay have some mechanical component in inside it. So when they vibrate too much of high frequency, or when there is too much of vibration, their lifespan might get decreased, and some might get hit because of the high vibration, because they have the electromechanical structure inside. They have the spring, they have the solenoid valve, yes, solenoid structure there, so that they can attract and repel the relay plunger. So so, so vibration, it's depend on the kind of relay you are using. And third consideration you can take is the rating of the load voltage. So there are various kind of relay that can take a certain load as a as a other side, as a output side. So some relay can work from 0 volt to 220 volt or 500 volt. Some have even greater voltage. So these are the things, few condition, environmental condition and other things that you need to see on about the relay specification, whether they are good for your design or not.
So, are there also some specific industry standards or certifications that the relay must have?
Yeah, yeah. So for the electromechanical relay, there are few certification as well, and for the solid state relay, there are the certification as well. So relay must do some for some kind of healthcare and other equipment. Those relay must be qualified the CE certification, and then ROHS certification for the for the environmental and other compliances. Then another certification those relay might need to qualify is IEC International Electrotechnical Commission certification. Then some are also require the ISO certification. And there are some military, these relays are also used in some kind of military equipment or military waste devices, electrical devices. Then they have to qualify those MIL standard certifications for the military grade relays. So based on the different kind of use cases, these relay must qualify certain certification as per their use. So if you are designing some kind of relay, or if you are using the relay for your design, then you need to first see in what area you are going to use that relay. It's a medical, it's a military, it's a defense, it's a space, and then you have to check the compliances and certifications that is needed by your for your product, and your relation must comply those certifications for your use.
So, what are the different types of relays that are available in the market?
Actually, there are various types of relays are available in the market, right? And each designs for the specific application and operating environment. For example, electromagnetic relays (EMRRs) are normally used for the wide range of applications available in the various voltage and current rating. For example, SPDT, single pole double throw, and DPDT, double pole and double throw relays. Another is this is the general purpose relay. Another is power loads, typically above 100 ampere. For example, relay for 100 volt, relay for 220 volt, used in industrial control system. And another is the which is the normally available in the market is the reed relay. Reed relay contains a reed switch sealed in a glass envelope, known for the fast high reliability. So these are the for example of the reed relays. It is used in telecommunication and instrumentation. These are the types of the EMR available in the market: general purpose relay, power relays, and the read relays. Another relay is the solid state relay. There are two types of the solid state relays. One is the ACSSR, means which are the used full for the AC purpose, used to switch AC loads, no moving part, provide silent operation, and are suitable for the high frequency switching. And for example, SSR used in the heating systems where there is no wear and tear. Second is the DCSSR, where it is used. DCSSR are used to switch the DC loads, known for the durability and the fast switching. For example, SSR used in automotive applications. And the third is the which is the available in the market is a hybrid relay. Hybrid means combination of electromagnetic and state relays. Means combination of EMR and the SS or solid state relay. It provides the benefit of both electromagnetic, electromechanical and the solid state technologies. For example, these relays means high hybrid relays are used in the application requiring both high current handling the silent operations. So in these cases, and third is the time delay relays. Few relays are available which have some delays. So delays the connections of the load after the control signal is applied. For example, where time delay relays are used, so time delay relays are used in a motor control circuits to prevent ingress current. And another type of relay is the off delay relays. Means delay the disconnections of the load after the control signal is removed. For example, such type of relay are used in the lighting system for the gradual shutdown. And the fourth type of the relays are the latching relay. Few relays are in the form of latching. Single coil latching relays changes the state of a single pulse and remains in the state until another pulse is received. So such type of relay is also available in the market. For example, where single coil latching relays are available, these are the used in a memory storage and switching application. Another latching relay are dual coil latching relays. It uses two coils to latch the either position. Where it is used in the telecommunication and the power distribution systems. And another relay which is the easily available market is the automotive relays. Miniature automotive relays. These relays are designed for the low voltage automotive applications such as the controlling light in the motor. For example, used in the car headlight circuits. This is the automotive relay. Another is in this category automotive relay is the heavy duty automotive relays. These relays are designed for the high current automotive application such as the starter motors and the fuel pumps. For these types of relay, heavy duty relays, used in truck and the heavy equipment systems. And the another relay which is available in the market is the signal relay, low signal relays used in switch small current and low voltage, typically in electronic circuits, which we normally use here. So, for example, these are used in the audio and the video equipments. Another type of relay which is available in the market is the protective relay. Protective relays are the relay which protects your instrument, such as the overcurrent relay. It protects the circuit from the excessive current by disconnecting the load when the current exceeds in the load. When by mistake, if excess current is flowing in the operator, then this signal relay automatically switch off and protect your loads. Where it is used in the power distribution network. Another relay is under voltage and over voltage relays. Few relays are also available in the market which protect the circuit from the voltage anomalies by disconnecting the load when the voltage is outside a preset range. And where these are used in the power supply systems. On the last relay, which is commonly used in the PCB mount relays. PCB mount relays is mostly used in electronic circuits, and these relays are designed for mounting directly on the printed circuit board, used in various electronics and control circuits. For example, it is used in home appliances and industrial control panels. Another is hermetically sealed relays. Hermetically sealed relays are normally sealed in an airtight enclosure to protect against environmental factors such as moisture and dust. Where these are the used, hermetically sealed relays are used in military and aerospace applications. So in brief, we may say that each type of relay is suited for a specific application with the feature tailored in the needs of those applications, such as load capacity, switching speed, durability, and environmental resistance. So when selecting a relay, consider the specific requirement of your application, including voltage and the current rating, switching frequency, and the environmental current. So there are various and every type of relay based on your requirement you can purchase from the market. That's all.
Okay. Okay. So, how the electromechanical relays and solid state relays work?
So basically, electromechanical relay has a plunger with the spring and one coil that energizes whenever you want to push the plunger. So in electromechanical relay or any all other kind of relay, there are various types like SPST, DPDT, or SPDT. So what do those things mean? So suppose that if the SPST relay, so it means single push, single throw. So what the plunger do when it moves, suppose that it's a plunger, so it push it's the single push, like one plunger is pushing using the electromechanical relay, and this is the contact of the other side of electrical appliances. So single push, single throw. So when the coil energizes, it push out this plunger to make a contact and close the circuit. So this is the single push, single throw relay. So what then is the DPDT relay. So this is a double push, double throw. So it have two electrical contacts that is either live wire or the ground or live or neutral, whatever it is. So it has two contacts and two contacts from the plunger side, and it's a single push, double throw. So whenever the coil is energizes, it will push this plunger towards both of the contacts at the same time. So then is single push, double throw. So what will happen? So there is a two contacts here this side, and this is only one plunger, and both of these contacts will get closed using the single throw of the relay. So these kind of electrical plunger setting, mechanical setting inside the electromechanical relay. And then apart from this plunger, it have a coil, electromagnetic coil. So whenever you want to make a contact between the NOC, NOCs that is normally closed, and there is NC that is normally closed, or NO that is normally open. So this is the normally open position. This is normally closed position. So to change this position, they have the electromagnetic coil inside that. So whenever the current pass through the coil, it get magnetized, and this plunger either get pushed from this side or this side to make a contact. So some relay have the spring with the plunger. So whenever it get magnetized, it puts towards the contacts, or and when it is not energized, then using the spring, it go back to the position. Or some use do not use the plunger, so some use the both side of electromagnetic coils. So both of the things are controlled by the energizing different coils. So it depends on them. So these are the functions, and these are the internal connections and internal structure of the electromechanical relay that you generally use in the DIY projects, or might have seen the market, those blue color relays there in the market. So second is the solid state relay. So these relays have the circuit instead of, by the name you can figure it out, solid state relay. So using this term you can figure it out. This relay do not have any kind of mechanical structure or mechanical movement inside it. So like in electromagnetic mechanical relay, they have the mechanical moving components, and that plunger will move with the spring or some kind of electromagnetic coil by energizing the electromagnetic coil. But in the solid state relay, these things are not there. They are simple circuits inside which they are the semiconductor circuit using which we can control the contacts of and flow of the current inside it. So what do this solid state relay have? So as I have already told you earlier, that relays are the components that gives you the power to switch each control the one electric circuit to the other electric circuit, while both of the circuit are electrically isolated. So one thing is clear, that two circuits must be isolated. If I am using DC to DC circuit, or one AC or one DC circuit, or one AC and then other is the DC, then in such circuit, both the circuit are totally electrically isolated. So how do we control in the solid state? Because there is no electromechanical plunger. So generally, most of these solid state relay have the combination of tristor and the diac to control and make a solid state relay, and that can be controlled using a semiconductor gap and PN junction, so that electrical can flow. And the other part of the circuit get controlled and isolated using the opto isolator, or you can say opto coupler. So what the opto coupler do? So both the circuits are different. In one is the AC, another is the DC, or one is the low voltage DC, another is the high voltage DC. So both are the different circuits, and both are electrically isolated. So they are coupled using the opto oscillator and opto coupler. Opto coupler. So what's inside those opto coupler and opto oscillator? They have a one photodiode inside it, and one LED inside it, and that is wrapped inside inside the chip. So the other part of the circuit get energy or get the signal using the light. So both the circuits are electrically isolated in a way, but they are coupled with each other. They can communicate with each other. They can sense each other's signal using the light. So they are connected with the light signal, but they are electrically isolated. They are disconnected using the electrical signal. So in electrically they are isolated, and optically they are coupled using the opto isolator or opto coupler. So if I want to control the solid state relay, I simply give the signal to the opto coupler, and the LED on the opto coupler will glow, and the other side of circuit will receive the signal using the photodiode or LDR, and the circuit get complete, and then it uses the tristor or diac, whatever it is, to complete the circuit and turn on the circuit on the other side. So you can see in the solid state there is no moving part, and they use the optocouplers to couple each other circuit, but they are electrically isolated. things. So this is how both different type of relay work.
Okay, so how to choose what kind of relay is needed in the circuit?
So for choosing the what kind of relay in the circuit, there are various factors that you need to consider. One is the load, and this is the kind of current you are using. And secondly, the switching frequency, that how frequency and switching because suppose that you have to choose between whether I need to use the what's a solid state relay, or I need to use the electromechanical relay. So if you need a very high switching without need of any kind of noise, then you have to go with the solid state relay, because solid state relay are especially designed to do the very fast switching. There is no delay between the signal and the switching. It's very fast switching. So that's why we have designed the solid state relay. That's why we need the solid state relay. And second thing you need to consider is the noise, because in the electromechanical relay, they have you will see the you can hear the noise whenever you are turning on and off the relay electromechanical. You might see a noise tick tick. So there are a lots of relay in the line, if you're controlling a lots of appliances in the line, and then you turn on the switch, then you will hear tick 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 sound a lot, and it will very noisy, and you can't withstand with that noise so much of large lots of relay are there, and it's so noisy. So if you want to avoid this noise, then you obviously you need to obviously you want to choose the solid state relay, because they don't make so much of noise, and they are very smooth to work, and they are very very what's a very easy to work, and very fast to work. So if your circuit need a fast switching fast sorry if your circuit need fast switching, if your circuit need uh, the low noise switching, then you can consider the solid state relay as your design. And if these things, the fast switching and this noise thing is not needed, then you can use the electromechanical relay. And the third is the efficiency of the relay. So if you are using the electromechanical relay, so then I have already told you that inside that relay there is a electromagnetic coil that energizes and to move the plunger. So suppose that if your light is in the on position, so this coil get magnetized and it's move the plunger towards itself to make a contact and close the circuit and turn on the light. So as long as that light is on, as long as that light is on, this electromagnetic coil need to be get magnetized all those along the time. So in all this time, this huge amount of energy is getting consumed by this electromagnetic coil, and it also get hit because of that as well. So it might one is the heating problem is there, there, and another problem is the efficiency problem, because the coil is continuously using the energy to get it magnetized to move get the plunger to fix the plunger at that position. But in the solid state relay, you might not need that much of energy, that much of current. It can be very small current to switch on the large AC loads, because they are just PN junctions, PN junction based device. So on the electrical efficiency side, the solid state relay is the good choice. So if you need a low budget, if your projects and your device didn't need very fast switching, didn't need the very silent switching, didn't need the very efficient, then you can choose the electromechanical relay. Otherwise, it's better to use the solid state relay, because they are better in many ways.
Okay, so discussing about the performance and efficiency, which relay perform better, electromechanical relay or the solid state relay?
So it's obviously the solid state relay performs better, but in some areas the electromechanical relay is also good, because in the solid state relay it's the PN junctions things, and the things are controlled by this. So if some kind of short circuit will happen, then it is very bad for the things, and you need to add some kind of what say in some kind of fuses there to protect the circuit. But in the electromechanical relay, they are the electromechanical contact. So if there's some kind of short circuit behind the other circuit, they might not affect the other side of circuit, and it might be might be not that much of dangerous, because it's the plunger and the good context between that is not the PN junction. And for the efficiency sides, the solid state relay is always better than these, because this solid state didn't have the electromagnetic coil, these n numbers of coils to get it energized. And on other side, the size, if you check the size of the solid state relay, they are generally thinner or smaller size. You can find very small and thin size the solid state relay, while the solid, while the electromechanical relay need to have the coil, L number of coil, then the plunger, then the spring structure. So overall size of the relay will big. So if there is a space problem in your design, then don't use the solid state. Don't use the electromechanical relay. Use the solid state relay, because they are very space efficient and they are power efficient as well. So overall, the solid state relay is the best choice for the energy efficiency, for the power efficiency, for the for the switching efficiency, the switching fast, it switches very fast, and all other different things, and the size as well. So overall, solid state relay can be the good choice for the circuit, and they are more efficient than the electromechanical relay.
Okay, so you were also talking about the noise. So, is electrical noise a concern in the applications, or how might it affect the other components of the system?
Hello. Yeah. Electrical noise is very concerned in the various applications. Electrical noise, which is also known as the electromagnetic interference (EMI), can be a significant concern in the many applications, especially those involving in sensitive electronics components or the communication systems. Here, you can consider following parameters such as the interference with the signal integrity. In this, data may be data corruption. Electrical noise can corrupt data signal, leading to errors in data transmission and processing. So this is a crucial in the communication system, computers and the data acquisition systems. And another is reduce the signal quantity. Noises are reduced. Noise can degrade the quality of the analog signals, causing issues in audio and video equipments and precise measurement system. Another is the malfunctioning of the sensitive components, microcontrollers and digital circuits. Noise can cause false triggering, misinterpretation of the logic levels, and the malfunctioning of the digital circuits and the microcontroller. Sensors and actuators interference can affect the accuracy of the reliability of the sensors and actuator due to noise, leading to incorrect reading and the uninterrupted actions. Another is the harm to power supplies. Noises, let's say voltage fluctuations. Noise can cause voltage spikes in the which may stress power supplies and lead to their premature failure. Another is regulation issue. Noise can interference with the regulations issues. Mechanism in power supplies causing instability in the ripple output voltage. Ripples which are generated in the output of the voltage in the regulated voltage may create a problem due to noise. And neither wireless and wired communication, EMIs can cause communication error in both wireless as well as the wired systems, leading to loss of data, reduced bandwidth, and the increased latency. Network and equipment problem create. Networking equipment like routers and the switches can suffer from the reduced performance or connectivity issues due to electrical noise. Also, component lifespan may reduce due to noise, such as accelerated wear. Continued exposure to electrical noise can accelerate the wear and degradation of electronic components, reducing their lifespan and the reliability. So mitigation strategies, it also create a problem. Proper grounding and shielding ensures all components are properly ground to reduce the impact of EMI. Use shielded cable and enclosure to protect sensitive circuits from the external noise. These are the remedies of the noise. Another is filtering. Employ EMI filtering on power lines and the signal lines to attenuate unwanted noise frequencies. Use ferrite pleats and chokes to suppress high frequency noise. Circuit design technology is also very used. When you are designing the PCB with proper layout and technique, such as separating analog and digital ground, minimizing the loop areas and using ground planes. Implement a differential signal to reduce the impact of the common mode noise. Isolation is very also important parameters to reduce the noise effect on the circuit. Use optocoupler, transformers, and the isolation amplifiers to electrically isolate sensitive components from their noisy parts of the circuit. And decoupling capacitors. These are also very important. Decoupling capacitors, when you are using in the circuit of a decoupling capacitor, it reduces the power pins of the integrated circuit to filter the high frequency noise. High frequency noise passes through the power pin of the IC. So, when you are using a decoupling capacitor at the pin of the power of the IC, then the high frequency noise will reduce. Another is short switching technology. When you are using short state relays on MOSFET based with the short switching technique to minimize the generation of the electrical noise during the switching, means when you are using electrical switch, then it may create some sound. When you are using short switches, SSR, then it will not reduce the noise. So you can increase the quality of the. In brief, we may say that electrical noise is indeed a common in many applications and can have a wide range of the negative effects on the connection components or systems, including signal corruption, malfunctioning of the sensitive components, power supply issues, communication errors, and reduced component lifespan. By implementing the proper grounding, shielding, filtering, and isolation techniques, along with the careful circuit design, the impact of the electrical noise can be significantly mitigated, ensuring the reliable operation of the electronic circuit.
Okay, so are there cost constraints that might favor one type of relay over the another? Should I repeat my question? Sorry, am I audible?
Yeah. Can you repeat?
Yes, yes. Are there cost constraints that might favor one type of relay over the another?
Yeah, generally, the electromechanical relay are little bit more efficient from the cost side. They are you can get in the market in lower cost, but the solid state relay are generally take more cost and it will cost you more. So they are relay that the solid state relay are more cost efficient and rather than the the electromechanical relay, because but in some cases, the for the smaller projects, for the smaller kind of DIY kind of projects, or smaller kind of project where you not need more fast switching and other things, then it's best choice and best copy the electromechanical relay are most cost efficient, while the solid state relay might be cost too much. But in the long term lifespan, for if you check the lifespan of the relay, then the solid state relay proved to be more, because it's the one time investment in the solid state relay, and you will get the longer lifespan. But if you're not using the device for the longer lifespan, you need the shorter lifespan, then the electromechanical relay is the best choice, because it's at the one time cost is really low, and but its lifespan is low as well. So if you have the low, if you need to change the device very frequently, and you don't invest so much money in the good quality relay, then you can, it's better to use the electromechanical relay. Otherwise, you can use the solid state relay if you are going to use it for the long life, if you want the long life span and the energy efficiency as well. So in such cases, you can use the solid state relay.
Okay, so last question from my end. What are new and upcoming technologies in a switching system that can replace relays?
Yeah, so there are few new technology in the relay that are coming in the markets, and that have already come. That one is the MEMS based relay, that is micro electromechanical equipment. So MEMS based relay. So they have very small, very thin micro mechanical movement inside them, and micro mechanical things inside them, and they can control a large number of load while taking a very small amount of energy. So those MEMS relays are not coming in the market. There are lots of company like there you find in the market that are selling the MEMS based relay. They are more efficient than those electromechanical relay or this SSR relay, solid state relay, because and at the advancement of this MEMS technology will increase in the future, these relay will become more accurate, and you will see more the space efficient as well. So basically, if you use the solid state relay or if you use the electromechanical relay, both, if you see the both of the relay for the high current load, for the high power switching, then both size are very large. They often come in this size or very large size. But if you see the MEMS relay in compared to the both, they are more power efficient, and they are very small size, a small footprint SMD relays are there. So with the advancement in the MEMS technology, these MEMS relays can you can see that these MEMS relay can start capturing the market and replacing those SSR and electromechanical relay with them, with the advancement in the MEMS technology. So these are the few technology that came in the relay side as well, that can help you in controlling the larger number of load and more efficiently in a smaller footprint, and in a smaller devices as well. So these are the few technology that can that are developing in the future.
In this live discussion. Thank you for your time, Ashwini ji and Suresh ji. And also, if our viewers are having any question, they can post that question to the comment section. We will definitely get back to them in the next live discussion. So thanks for your time.
Um,